Hello and welcome to section 2.b, graphs of rational functions. And so today we're going to talk about a slant asymptote. And remember when I talked about end behavior of a graph, horizontal asymptotes, we talked about what happens if the numerator has a power higher than the denominator. We said that there was no horizontal asymptote. So when you're looking at this, the numerator has a degree of 2 and the denominator has a degree of 1. So we are basically talking about no horizontal asymptote. But if the numerator is exactly 1 more than the denominator, we have what we call a slant asymptote. So the first thing I did here is I graphed the function, and actually let me go back to your y equals. There's how I typed it in. X squared minus x divided by x plus 1. And so then when I graphed it, I get something that looks like this. And so you can see that there's a vertical asymptote at x equals -1, but there is no horizontal asymptote. But you can see that there's some function here that is giving me this line that would be basically what's the end behavior. So when the numerator is exactly 1 more than the denominator, we find a slant asymptote by doing long division. So let's model that right now. And so if I have my function of x squared minus x, and I'm going to divide that by x plus 1, well, I have to add on the 0 term because I'm missing that. And so when I go ahead and divide this, I have to make x look like x squared. So I'm going to multiply by x, and that gives me x squared plus x. Now if I change the signs on the bottom row to subtract, then when I add straight down, I get -2x plus 0. So that means that I'm going to have to multiply this x out here by -2 to make it look identical. So I get -2x minus 2. And when I change the signs on the bottom row to add straight down, I end up with 2. And so I have a remainder of 2. So this is really 2 over x plus 1. But when we're talking about a slant asymptote, we're really only concerned about that function right there. So let me draw that into our graph here and so to show you. And so I'm going to use x plus or x minus 2. And we're actually I'm going to change the thickness of the line so that it's a little bit easier to see. And so when I graph it, there it is. There's our slant asymptote as a graph. And so we find it, and when you do long division, you don't worry about the remainder for the slant asymptote. It's just what you get as you divide it in. So x minus 2 is the function, is my slant asymptote in this case. So then if I have a function and I graph this function, so let me go back here and get rid of these graphs, and I graph this function, you'll see that I get this thing right here. And so I'm dealing with f of x equals 3 over x times x squared minus 2x, and you'll notice, okay, so there's my graph of that function, and we'll go back to my y equals. There's my y equals if you're looking at the highlighted one. And they're asking me, the question is, what do you notice as x equals 0 on the graph? Well, I made a table. I used the table of this graph, and you'll notice that there is an error. And you may be asking yourself, well, how do you get that error? Well, if you notice, if I was to take the top function or the bottom function and factor out the like term, I get x minus 2. Well, these x's cancel out, even though you don't see at x equals 0 something going on there. There's not an asymptote. You'll notice that these guys would cancel out, which means that there's a hole at x equals 0. And then this x minus 2 is a vertical asymptote, and that's what shows up at x equals 2. And so that's where this vertical line is showing up, and there should be a hole when you look at the table, so you got to be careful of that, and that's what we're talking about. So if you have any questions about this, please come to class prepared to ask them, and we will talk more about this.